going to discuss one more part, data analysis project. Okay, so in today's video we are going to perform data analysis on loan approval dataset. Okay, so first we need to import the useful libraries which we need to perform data analysis. Okay, here we have pandas, numpy, matplotlib, seaborn. Okay, so above two libraries are for data manipulation or loading data and performing any operation or data set. We are using above two libraries, and for visualization we use matplotlib and seaborn. Okay, so let's start. So first you need to import your data set. For importing data set we use the pandas function, which is read_csv. This function used to load the CSV file. Okay, for running these cells we use shift enter. Okay, now let's, for showing above 5 records we use df.head function. These all were the pandas function. I made already separate video on the pandas function which we use in data science and data analysis. Okay, so you can go and check it out, that video. Okay, the link is present in the description. Okay, here we use header function to read top 5 rows for our data set, and we can read as many as rows we want to access. If I rotate 10 here, then it will print the top 10 rows. Okay, next is our shape function. Shape function returns the shape of our data set. In our data set we have 4269 rows and 13 columns. Okay, and by using this info function we can read name of our each column, data type of each column. Okay, so you can see that we have 3 object columns and remaining were the integer columns. Okay, so next is, so our next function is to find null values present in our data set. To find null values present in our data set we use null function, but some of the null values we use sum function. Okay, if we did not use sum function here, it will return us with the metrics of our data set. Okay, so if I remove sum function from here, we can see that it will print the metrics of true and false. Whenever there is no null value is not present in our data set, it will print false, and if any value contain any column contain null values, so at that place it will return true. For example, if here the nn value is present, then instead of false it will return true. Okay, for some of these values we use sum function here, so it will print the total number of null values present in each column. Okay, similarly we can check for duplicates present in our data set. So in our data set there is no duplicate value is present. Okay, if I did not use the sum function, it will return the duplicate value for each column. Okay, if any column is containing duplicate value, then any row is containing duplicate value, then it will return true instead of false. Okay, so for some of these values we can use sum function to find total duplicate values. Okay, so check for unique values in each column. So here we use df.n unique function to find the unique value present in our each column. Okay, so here we have in loan ID column we have 4269 categories. So basically it will return the number of rows present in our data set. It will present by using loan function. Okay, and in number of dependents we have many unique categories. We have 6 unique categories. Okay, in education we have 2, graduate and non-graduate. Okay, in self-employed we have yes or no. Okay, we can also check it out from here. Okay, as you can see here, in education we have graduate, non-graduate, 2 categories, and employed we have no or yes. Okay, so so that's how it will return the unique values for each column. Okay, so you can see here the number of unique values presented in each column. Okay, and here our loan status is our target variable. Okay, which return approved or rejected. Okay, let's check the statistics of our data set. So here we use describe function, which will return the descriptive statistics of our data set, which means it will return the mean, standard deviation, minimum value, maximum value, count, and 25%, 50%, and 75% of our data set. Okay, so if I did not use this include here, it will only work for the numerical columns. Okay. If I use include here, it will work for each and every column present in our data set. Okay, for specifically for a categorical column it will use unique, top, and frequency function. Okay, so in our function it will return the value of unique, top, and frequency. Okay, for numerical column the nn value is present because it will because these were numerical column, it will not have the unique top and frequency. Okay, in categorical columns there is a classes. Okay, so either the person is graduate or not graduate. Okay, so it will entity quantity, there are two categories. Top is graduate, which means the maximum number of people are graduate, and the frequency of graduated peoples are 2144. Okay, that's similarly it will return for each column. Okay, now let's explore our data. For exploring our data, first we need to separate our numerical column and categorical column. So let's see which one is a numerical column and how many categorical columns and what are they. Okay, so for finding, here I used the for loop. Okay, here we have feature in our data set. Okay, dot column if the data set feature dot d type equals to object. So basically it will loop around all the column names and finding if the data type of any column is O, which is object. Okay, which is not object basically. Okay, it return here d type is not equals to O, which means if the data type is not object, then it will store in this list of numerical features. Okay, and if it is equals to object, data type of any column is equals to object, then it will list under the categorical feature. Okay, now here we are printing the number of numerical features and name of the numerical features, and here we are return the length of list of categorical features, which means number of categorical column and name of the categorical columns. Okay, so as you can see here, it will return the there is 10 numerical features. The name of this list of the numerical features are mentioned here, and we have 3 categorical features, and the list of categorical features are written here. Okay, now the next is we need, if you want to return the column names, or if you want to read the column names of our data set, then you use ds.columns function. Okay, as is present here, so you need to mention df.columns to print the column names, and you can see here the space. See here the space is present in front of each column name. Okay, so for removing this space, here I created one function which name is delete space. Okay, here I'm providing the dataset as a parameter, and df.columns equals to df.columns.string.lstep function. Okay, so this lstep function will remove the space in front of each column name. Okay, and it will return the dataset. Okay, so here I call this delete underscore space function. Okay, and after that, if I print the column name, then here you can see that there is no space in front of each column name. Okay, so if df name columns equals to, so here I am rewriting this credit score name of this column, which means credit score. Okay, so here it is written this, and I am removing this name with the credit score. Okay, in place is used for replacing any or creating any changes in your main data set. Okay, so for that we are using in place. Okay, now here we have this head function. Again, we check whether our name is replaced or not. Okay, so you can see here the name is replaced with the credit score. Okay, now here we are checking the here we are checking for each categorical column what are the different values, or what were the different categories or unique values is present. Okay, so here you can see that df, here we provide the column name dot unique is used to find the unique values in our present in our column. Okay, so in loan status we have approved and rejected. In self-employed we have yes or no. In education we have graduate or not graduate. Okay, so in our next slide we are counting for rejected and approved application. Okay, so here we use normalize equals to true because it will return the percentage of approved and rejected application present in our data set. Okay, so here we have 62% approved application. Sorry, so here you can see that 62% was approved application and 37% is rejected applications. Okay, now let's see how we can perform exploratory data analysis on our data set. So it is a type of data analysis in which we explore our data. Okay, so this was basically a step of every data analysis project, ED. Okay, it's short form is EDN, full form is exploratory data analysis. Many times this will ask in data analysis interview what is the full form of ED and what is ED. Okay, so first we need to find the correlation between the numerical columns present in our data set. To finding the correlation, we are using this df.core function. Okay, CORR. Okay, this core function to find correlation between this data set. When the value is present in negative or 0, then there is no correlation between that columns, and if the value is greater than 0 and less than 1 or equals to 1, which means the columns are highly correlated with each other. Okay, so let's understand this correlation by visualizing it. Okay, so you can see that the boxes which is having the black color, which so this means these columns are not correlated with each other, and remaining all blocks are of different colors. Here you can see that how they are correlated and how much they are correlated with each other. Okay, so for this plot named as heat map, sorry. Okay, this was a seaborn function which we use here, which named as heat map. Okay, and here I'm using the figure size, and this was our main function. I provide this function here. Okay, and use plt.show to show this plot. Okay, and next is our count plot. You can use count plot to count the here we use count plot to count the how many approved application, how many rejected application. So here you can see that approved application is more as compared to rejected application. Okay, so you can this is also a seaborn plot. Okay, so for the count plot we need to define one the target column. Okay, which is here is loan status, and here we are providing the data set. Okay, same we are used count plot for self-employed, and similarly we are plot the count plot for loan terms. And here you can see that we need to credit score. Credit score is very important if we are performing loan analysis, or if we are taking loan from the bank. Credit score is the important factor. Okay, so here I am converting this numerical column with some category. Okay, so here I am converting or giving or creating a more column in which if the credit score is greater than 300 or less than 500, then it come under the category of low, and if the credit score is greater than 500 or less than 600, then it will come under the category of mid and high. Okay, so after converting or creating one more column which named as a credit group, you can see the unique values present in our sorted in front of the cell. Okay, so here we have high credit score of 2,136 people, and low credit score for 1,406, and mid for 727 people. Okay, and let's count. Here we are creating one more count plot with credit groups and loan status. So as you can see here, who is having the high credit score are more chances to get loan approved, and for low credit score there is low chances for getting loan approved. Okay, and for mid there is both chances. Okay, it may be approved but it may be not. Okay, there is very less difference between both of them. Okay, and next is we are plotting a histogram. Okay, here we are using plt.hist function. Okay, and here we are providing the column name. Here we are providing the bins, and these bars are called bins, and here we are providing the edge color. So the border of this or the outline of these bars are known as edges. So the edge color is black, and here we provide the title and plt.show. Okay, so this was the income annum, which means the annual income plot. Okay, and this histogram is for loan amount, and similarly this histogram is for residential assets value, and here we have dependent and loan status box plot. Okay, so basically box plot is also a very important plot in the sense of data analysis, data science, or if you are going to implement any machine learning model on any data set, first you need to plot a box plot, so that it will gives us the whatever the minimum maximum value outliers is present in our data set, it will return which will be visible on our box plot. Okay, so as you can see here, we are plotting the box plot between loan and number of dependents. So here you can see that in the maximum number of dependents is 5 whose loan get approved, and similarly it will for rejected. Okay, and for the middle value, okay, which is between 2 or 3, the loan get approved, and for rejected the value is between 3 and 4. Okay, the person is having dependents between 3 and 4 or more, these are having high chance to be rejected. Okay, for loan application. and this was the box plot, another box plot for credit score and loan status. And here you can see that this was the outlier for rejected, and this, and here we have the outlier for our approved. Okay, so here you can see that if the credit score is greater than 300 or above, or you can see that if the credit score is greater than 600, there is a high chance for the loan approval. Okay, if the credit score is less than 700, or you can say that less than 500, it is having a high chance to be loan will be rejected. Okay, there is a high chance of rejection. Okay, so in next plot we have this scatter plot. So in scatter plot you can see that here we are plotting the scatter plot between the credit score, loan amount and loan status. Okay, so if our credit score is between 600 to 500, which means that we have maybe 550, 550. Okay, if we have in the credit score which is 550, is less than 550, there is high chance of loan to be rejected. Okay, and if we have the credit score greater than 600, then is high chance for loan approval. And as you can see here, the loan amount. Okay, for high amount of loan and you are having less credit score, there is very less chances for your loan approval. Okay, but if you are having the credit score greater than 550, there is a high chance for having loan approval. Okay, so that's all for this video. I hope so this data analysis project is clear to everybody. I hope you enjoyed this session. Thanks for watching. Like, share and subscribe for more such videos.